Today we're talking about graphing quadratics in standard form. Hey guys, Jesse from Capstone Academics here. Today we're going to be talking about graphing quadratics in standard form. Today I'll be talking you through 7 carefully designed problems that'll illustrate all the subtypes that you might see. There will also be a 2-problem test at the very end, which if you can pass it means you're ready for whatever you might see on your quiz or your test or your final, SAT or ACT, etc. So you'll be graphing quadratics in standard form when the equation looks like this: y equals ax squared plus bx plus c. So first things first, guys, I'm going to go ahead and put an outline of the process on screen now. What you want to do is pause it and take a screenshot, or pause it and copy everything down if that'll help you memorize it. I'll also have a link to this picture in the description below so you can access it that way if you want, but in any case, take a second, pause, review the process, because knowing the big picture is definitely going to help you moving forward. Alright, so now that you guys have a good idea of how this is going to go, let's jump right in. Okay guys, so jumping right in, we're just going to use the x equals negative b over 2a equation to go ahead and get our x-coordinate of our vertex as well as the equation of the axis of symmetry, which is that vertical line that splits the parabola directly in half. So if we just do negative b over 2a and we go and identify our a, b, and c, they're the coefficients on these terms here. So a is 1 in this case, b is negative 6, and then c is 8. So if we do negative b over 2a, that'll be the opposite of negative 6 over 2 times 1. So we get positive 6 over 2, and x is positive 3. So if we go over to 1, 2, 3, this is going to be the axis of symmetry and the x-coordinate of our vertex. Most teachers will want you to actually plot this, so keep that in mind, okay? So we have the x-coordinate of our vertex. Now we just need to go ahead and get the y. So we're going to do y equals, just plugging in that x-coordinate, 3 squared minus 6 times 3 plus 8. So y equals 9 minus 18 plus 8, y equals negative 9 plus 8, and then y equals negative 1. So we go to 3, negative 1, go ahead and put our vertex down, and then kind of a nice trick here, a pro tip. Whatever this a value is actually going to tell you how much you go up and over for your next points. So because this a is 1, you're going to go up 1 and over 1, to the left and to the right. And that's going to actually give you your first 3 points of your parabola. Now for some teachers this is actually enough. Some will only ask for 3 points, but a lot will ask for 5. So we're going to actually talk about the table of values approach for how you get all 5 values and actually show your work. But as a nice sort of pro tip slash way to check your work, just keep in mind that this number in front here is how much you'll go up and over for your first set of points next to your vertex. Now, the one thing you have to watch out for is if that a value is like a fraction, like 1/2 or something, because you'd think you'd go up 1 over 2. You'd think it would work a little bit like slope, but it doesn't actually. In this case, you'd go up 1/2 and then over to the right one. You see how I'm doing that here? So it's not super common that you're going to see this, but it is out there, okay? So just keep that in mind when you're using this. So let me just erase some of this so I can actually get some space. And we're going to make room for our table of values. So when you make your table of values, you're going to want to have your vertex at the center. So remember, our vertex is 3, negative 1. And what you want to do is just go down a couple x values and then up a couple x values from there. And then this is actually where the axis of symmetry is going to plug in, or come into play, because you can just plug in the lower numbers, like numbers closer to 0, because they'll keep your numbers a lot lower. And then whatever you get for y values for plugging these in, you're going to go ahead and match those y values for these x's. So you see what I mean here in a second. I'm going to make some room over here. So plugging 2 in, that would look like this. Y equals 2 squared minus 6 times 2 plus 8. So 4 minus 12 plus 8, negative 8 plus 8, and y equals 0. Now remember how I was saying you can go up 1 over 1 for your first set of points there? We're seeing that here. When we plugged in 2, we got 0 for our y. Now, the axis of symmetry splits this parabola perfectly in half, so it makes sense that the other point would be over here. Now, if you want, you can go ahead and plug 4 in, and you'll see that you end up getting y equals 0, so you can sort of trust this process if you want, or you could just trust me, but yeah, save you some work. So that's 3 points so far. Now I'm just going to plug 1 in, and we'll see what we get. So y equals 1 squared minus 6 times 1 plus 8. So 1 minus 6 plus 8, negative 5 plus 8, and y equals 3. So going up to 3 here, 1, 2, 3, when x is 1. I'm going to write that in the table of values. And remember, you can mirror it over here with a 5. So at 5, there's our last point. And like I was saying, most teachers will ask for 3 points or 5 points. So this is all you really have to do. Just connect it with a nice parabola on the left sides and right sides. Whatever you do, don't make this a V. I've seen teachers take off for that. So yeah, make a nice sort of U-shaped parabola. And that's our first basic example out of the way. If you guys are enjoying this video, please go ahead and hit the like button. Thank you, thank you. All right, gang, on to the next example. So you have to watch out for when there is a negative in front of this first term here, the x squared. So I'll show you what I mean. If we just go about our usual process of doing our like negative b over 2a, that would be negative 8 over 2 times negative 1. So positive 8 over negative 2, x is negative 4. So we go ahead and draw our axis of symmetry at negative 4. 1, 2, 3, 4. So vertical line here. There we go. Okay, and then we plug in our x to get our y coordinate of our vertex. So negative 4 squared minus 8 times negative 4 minus 15. Okay, here's what to watch out for. A lot of people will multiply the negative by the 4 here, and they'll get positive 4 and then square it. But think about why you can't do this. It's actually because of PEMDAS, right? So if you remember PEMDAS, it's the order of operations. So the exponents come first. You actually have to square this negative 4 before you multiply this negative 1 right here. It's super, super important, because if you don't do it this way, you'll get it wrong. So that's actually why I'm giving you guys this example. It's just a really, really common mistake. So I'm just gonna get rid of this here. Now, if we follow PEMDAS, we gotta square that negative 4. Negative 4 times negative 4 is positive 16, but it's negative 1 times positive 16. And then negative 8 times negative 4 is positive 32. And then I'll just copy down my minus 15. This then is negative 16 plus 32 minus 15. This part gives you positive 16 minus 15, and then y is 1. So we have the coordinates of our vertex. It's negative 4, 1. So to the left 4 and up 1, put that here. And then that's our first point. Now we create the table of values centered around our point, and we'll talk about how to use that pro tip once again with the a value. So looking at the a this time, it's negative 1, so it's going to be going down 1 and over 1, so our second 2 points should be here. Okay, it's just kind of a nice way of checking our work. Your teacher is going to want you to show your work for plugging the steps in most of the time, so just keep that in mind, okay? Now, actually, let me write my little table of values. I'll do my work on the left. So centered around the vertex, remember, like negative 4, 1, and then go down a couple x values, negative 5, negative 6, up a couple x values, negative 3, negative 2. Plug in the ones that are closer to 0 because it'll keep your overall numbers lower. So that's actually these guys, negative 3, negative 2 this time. So we've got y equals negative 3 squared minus 8 times negative 3 minus 15. So this ends up being positive 9 from that, but with the negative outside, it's like negative 9. And then positive 24 minus 15. That right there is going to give you positive 15 minus 15. And then there's that expected y coordinate of 0. So this gave us 0, which means negative 5 would also give us 0, and we're getting those expected points from using that a value going down 1 over 1. So we're on the right track, right? Now we just need those last 2 points in case your teacher calls for 5, which is super common. So remember to plug in the lower of the 2 coordinates, so not negative 6, it'll give you some pretty big numbers. We'll want to plug in negative 2. So this now, and then, so positive 4 out of that, but then times the negative 1 will make negative 4 plus 16 minus 15. So now we've got negative 4 plus 16 is 12 minus 15. Y equals negative 3. So negative 3, and then when we go and make that 1, 2, 3, we got a similar looking parabola just upside down, and that's actually what the negative a value does. It just flips it upside down. Doesn't change the shape though. There we go. Okay guys, so now we got to talk about when there's an a value bigger than 1, like the 2 that we're seeing here, because it's actually going to affect the shape of the parabola overall. So we're going to talk about that now. From now on, I'm actually going to only do 3 points, so like the vertex plus, one other pair of points, just in the interest of time, right? If you guys need those 5 points, just make sure to plug in that next x value and you'll get it, right? So just doing our negative b over 2a here. So we've got negative 12 over 2 times 2. So positive 12 over 4, so 3 for the x-coordinate of the vertex and the axis of symmetry. So we're going to do, here we go, with the axis of symmetry at 3, and then plugging that in to get the y-coordinate of the vertex. So we've got 2 times 3 squared minus 12 times 3 plus 18. So now we've got 2 times 9 minus 36 plus 18. So now 18. So this is the thing to watch out for. Once again with that PEMDAS, right? Do that 3 squared before multiplying the 2. Super important. Just follow that PEMDAS. So 18 minus 36 plus 18. So now we've got negative 18 from this, and then plus 18. And then we've got y equals 0. So at 3, 0, we'll find our vertex here. Let's make some room for, go ahead and getting the table of values here. We'll center it around the vertex. So we're going at 3, 0, and then go down a couple x values. Well, we'll only do 1 here. And then up an x value, in this case for 3 points. So we'll plug in the one that's closer to 0, so in this case the 2. So we've got 2 times 2 squared minus 12 times 2 plus 18. So 2 squared is 4 times this 2 is 8 minus 24 plus 18. And then this is negative 16 plus 18, so y equals 2. So over here, got 2 and 2. And remember the A trick, guys, super important. We should find our next set of points up 2 over 1 from the vertex. So that would put us right here, which is exactly what we found, right? At 4, 2, and 2, 2. So once again, that A trick really comes through. You just have to watch out for fractions, like I was saying. But otherwise, yeah, good to go. And go ahead and plug in 1. And use that same y value for 5 if you need 5 points total. Okay guys, so now we have that dreaded fraction in the front like I was sort of telling you about. It's just going to inconvenience you with in terms of the A trick, and then like depending upon whether you have a calculator or not, can be a little bit inconvenient. So we're just going to plow right through it, and I'll show you guys some ways to make your life easier as you're doing this. So go ahead and, of course, start with your negative b over 2a, so like negative 4 over 2 times 1/3. Now, when you multiply the 2 and the 1/3, you can put that 2 over 1, and just remember, fractions multiply straight across, okay? So this becomes negative 4 over, I would use parentheses here, it'll help you, 2 over 3. Now, in terms of how you divide a complex fraction like this, if you wrote it horizontally, it would look like this. Negative 4 divided by 2 over 3. So if you think about what that is, this should sort of trigger your middle school memory of division rules with fractions. That's really negative 4 times the reciprocal of the second fraction. So negative 4 times 3 over 2. And then you can multiply the negative 4 over 1 straight across, and you get negative 12 over 2. And then your x-coordinate is negative 6, okay? So 1, 2, 3, 4, 5, 6. And of course, if you're allowed to use a calculator, just use a calculator, right? Just make sure to use parentheses when you're doing the negative 4 divided by 2/3, or else your calculator will think that you're doing negative 4 divided by 2 and then divide that by 3, right? So it's actually going to give you a different result. Make sure you put this in parentheses. So there you are. Okay, now going back to this, let's go ahead and get that y-coordinate. We'll plug this in, so 1/3 negative 6 squared plus 4 times negative 6 plus 15. So now we've got 1/3 times 36, and then this is negative 24 plus 15. A third of 36 is 12, so 12 minus 24 plus 15, negative 12 plus 15, and then we've got 3. So over here at negative 6, up 1, 2, 3. There's our vertex. Let's make some space here for our table of values. I'm actually going to clear this over here as well, because we'll need some space to do some figuring. Okay, so making our little table of values, centered around the vertex, -6, 3. So here's the pro tip when dealing with fractions. See how the denominator here is a 3? If we don't plug something in that's divisible by 3 for this x right here, then we're gonna have a bad time. We're just gonna have decimals. It'll still work, okay? But you're gonna basically be dealing with some fractional values. It's gonna go like this. If we're using that A trick, we're supposed to go up 1/3 from this and then over 1. So yeah, what we're gonna wanna do to keep our lives easy, okay, is to go, whatever this denominator is, go that many to the left and to the right of the vertex. So -9 and then -3. That way, when you plug the -3 in, it's actually going to be divisible, as you'll see in a second, okay? So let's go ahead and I'll get rid of that. So when we plug the -3 in, it's going to be like y equals 1/3 and then -3 squared plus 4 times -3 plus 15. Now when we do our -3 squared, that's going to be +9. And then this is -12 plus 15. 1/3 times 9, you can put that 9 over 1, multiply straight across. This is just 9 over 3. And then this, I'll just go ahead and do this now. -12 plus 15 is +3. 9 over 3 is +3. And then it's plus the 3 there. So y is 6. So 6 and 6 for these guys. So we'll go up another 3 because 1, 2, 3. And then oops, forgot to go over 3. 1, 2, 3. There we go. And then 1, 2, 3. There we are. And you can see that this is much wider because it's growing 1/3 as fast as it usually does. Whereas that example that we had where A was 2, it was growing twice as fast vertically as it was when there's no coefficient there, when the coefficient's just 1. So yeah, with the 1/3, we're going to get a wider parabola. And yeah, make sure to make use of that trick where whatever this denominator is, you just go that far away from the vertex and you should be able to avoid decimals that way. And now for the weirder stuff where b equals 0 or c equals 0 or both actually, as you'll see in the third example. Okay, so with this one, we actually don't have a c value, but that's okay. It's going to work out just like you'd expect it would. We're just going to start out with our -b over 2a. So when we do that here, it's like -4 over 2 times 1. 4 over 2, 2 for the x-coordinate of the vertex and the axis of symmetry. We'll plot that here. And then, there we go. Plug in to get our y. So 2 squared minus 4 times 2. So 4 minus 8, y equals -4. So -1, -2, -3, -4. And then we'll know that because the a value is 1, it's going to go up 1 over 1. But I'll just go ahead and show our work for getting our other points real quick. So making a table of values centered around the vertex at 2, -4. We have 1 and 3 as surrounding x values. We're going to plug the 1 in to keep our numbers low. So like 1 squared minus 4 times 1. So 1 minus 4, so -3, -3, -3. As anticipated, these are at -3. Draw your graph. And so even though we didn't have a c value, this comes out to be pretty simple. Okay, so here's an example when b is 0, which looks a little weirder. So if you want to, you could plug in like a little x squared plus 0x minus 2 to just remind you that b is 0, or not. But like when you do your -b over 2a, this time it's going to be -0 over 2 times 1. So -0 over 2. -0 is just 0, and 0 divided by 2 is just 0. So that's the x-coordinate of the vertex and the axis of symmetry. So overlapping the y-axis there, and then just plugging it in to get our y-coordinate of our vertex. So 0 squared minus 2, which is 0 minus 2, which is -2. So there's the vertex right there at 0, -2. Let's make some room and just get our surrounding points here. So you guys are used to this trick by now, but the a value is 1, so we're just going to go up 1 over 1 to get our other points. And quickly, I'll show my work here. At 0, -2, we've got -1 and +1. These are equally close to 0, obviously. I'm just going to make life easy and plug in +1. to get the y coordinate here. So y equals 1 squared minus 2, y equals 1 minus 2, y equals -1. So you're still following the same process, and this is the way a lot of math goes. Just like, even though things look weird, just do the same things, right? Don't do anything crazy, just keep following the process and think critically, you'll be good to go. Okay, so last of the subtypes where b and c are both actually 0, but once again, we just sort of stick to our process where we're going x equals -b over 2a, and this time it's like plus 0x plus 0, if that helps. So it's going to help with a b. The c you don't really have to pay attention to, but I'm just going to take that away. So -0 over 2 times -2. So -0 over -4, again, -0 is just 0. 0 divided by 4 is just 0. So the x-coordinate of the vertex and the axis of symmetry is at 0 once again. And then we got to plug that in to get the y-coordinate of our vertex. So -2 times 0 squared. Think about PEMDAS, right? Not that it matters much here, but like exponent first. So -2 times 0 squared is 0, and then you end up getting 0. So the vertex is at 0, 0. So it's right there. And then we'll make some room to make our little table of values. But where's it going to go from here if you're using that A trick? It's going to go down 2 and then over 1. So we can put our points in there, but your teacher's going to want to see your work, which is why I keep doing this out, right, guys? So go ahead and make your table of values here, 0, 0. And then surrounding x values would be that. We're going to plug in the positive one because that's easier. And then just sort of showing our work here. 1 squared would just be 1, and then -2 times 1, and then -2 as expected. So -2, -2, and then draw your graph. And you can see it's thinner sort of vertically, right? And it's also flipped upside down by that negative in the front. Okay guys, time for the 2-problem test. If you can pass this on your own, then you should be pretty much good to go. Again, if you guys benefited from this, please do go ahead and hit the like button. It helps out the video quite a bit. Thank you very much. Okay guys, I know, this is super terrible, but some word problems have you actually graph in standard form with decimals involved. You will absolutely need a calculator for this, okay? I have a calculator, I'm using a calculator, it's fine, but I wanted to show you one of these. I know this is the 2-problem test, but it's sort of forcing you to use your process even when things get ugly, right? So I'm gonna go through this with you. When you do your -b over 2a, this time it's gonna be -0.05 over 2 times -0.02. So I would just do this in your calculator first. You're going to get -0.05 divided by -0.04. And when you do that in your calculator, you'll end up getting 1.25. So when you're forced to graph with decimals, you really just do the best you can. Like, I know this isn't accurate. This is like, 1.3 or something like that, but it doesn't really matter. Your teacher knows that it's not going to be exact, right? So x is 1.25, and then you go ahead and plug that into your equation. Again, you should keep this whole thing in your calculator. It's just going to be way easier. So use whatever calculator you're comfortable with, but I would suggest like a TI-84. Scientific calculators just aren't as great with plugging stuff like this in, but if you're more comfortable with scientific, like power to you, it's totally fine. So -0.02 times the 1.25 squared, I'm just going to tell you guys what you get from this, but you'll just put the whole thing in. You end up getting 8.03, okay? So if we go up to 8, 1, 2, 3, 4, 5, 6, 7, 8, here is 8, and by the way, this is 1.25. Your vertex is here. Now, should it be going right side up or upside down? Well, let's go ahead and look at the A value. If you notice, that A value is negative, right? So we should be going down. It should end up as an upside down parabola, like this. Hang on one sec. There we go. Okay, like that, somewhat. All right, and that's the shape that we're going to get, but let's go ahead and make our little table of values. So in the middle, we've got 1.25 and 8. Now, since you have a decimal x value, you can't really like go down 1 and up 1. I mean, you could plug in 0.25 and then 2 or 2.25 if you really wanted to. But in this case, it's sort of like just plug in whole numbers of x, and remember that the axis of symmetry won't work if you do it this way. I would just plug in 0 because that's super, super easy to plug in for these x's right here because you're just gonna get 8, right? Like -0.02 times 0 squared is just 0, plus 0.05 times 0, that's just 0, plus 8. So this was 8.03, by the way. I don't know why I didn't have that there. But when you plug in 0, it'll be 8. Now, when I plug in 2, you see how 0 is not the same distance away from the vertex as the 2 is. Like this is down 1.25, whereas this is up 0.75. So these y values are not going to be the same. So you're gonna have to manually crunch that out. And I've done this out already, so I just know that you get 8.02 from plugging 2 in. Now, if you go over here, it's gonna look like this. And then when you plug 2 in, there's 1.25, here's like 2. That's 8, so it's super wide, but that makes sense because that A value is such a tiny decimal. It's going to be really, really wide, but it is going to be going upside down. So there you go. Okay, so this is actually a projectile motion problem. Now, I'm going to be making an entirely separate video about word problems, particularly projectile motion, but for now we're just going to talk about how you'd actually graph one. So again, use your negative b over 2a, so negative 32 over 2 times negative 16, so negative 32 over negative 32, x coordinate's just 1, that's kind of nice, right? So here we go, at 1, and then plug it in to get our y. So notice the fact that I'm sort of ignoring that our x is now a t, right? The t really means x and the h really means y, but this may be how they frame it for you, okay? So when I'm plugging in the 1 for the x, that's really the t, but all good. So negative 16 times 1 squared plus 32 times 1 plus 20. So negative 16, because the 1 squared is 1, so it's like negative 16 times 1 plus 32 plus 20. So h is negative 16 plus 52, so this ends up being 36. So going up here, like roughly, let's just pretend this is 36, right? And then from here we'd go down 16 over 1. So down 16 to what is now 20-ish, right? And then over 1, and it would look basically like that. That's it. And that's all for graphing quadratics in standard form. If you guys found this helpful, please do go ahead and hit the like button. It helps out the channel and the video quite a bit. Thank you so much. Lastly, you're most likely going to be going on to learning how to graph quadratics in vertex form and intercept form. So I'm going to go ahead and leave links to those videos at the end here. Go ahead and check them out. They're super helpful. Thanks so much for watching, guys. See you next time.